Cerete. Well, that's the way we say hello in Greece. Hello children, how are you people doing? I'm saurabhkumardutt and I'm here to teach you people a little bit of mathematics. Now children, this awesome place that you get to see is actually the Naxos village in Greece. 4 to 5 kilometers ferry ride from Athens. Make sure you visit this place because this is a place which has amazing beaches, top gastronomy, and it also has many archaeological sites where you can dig some history. Further, there are some mountains where you can even go and do some trekking, which are by the picturesque villages. So guys, make sure you visit this place, and all the people of Greece that you go and meet there, do say to them, Cerete. In this note children, I'm going to start off this lecture of arithmetic progressions, which is in the syllabus of Icse in class 10, and I'm sure after doing this lecture you will feel confident in a sum which is pretty important for your examinations. So let's get ahead and let's quickly look up what an arithmetic progression is, and after that we will then be looking up this quintessential question, right? So let's say now that when we talk about an arithmetic progression, it is actually a series where what happens is every next term gets added by a fixed constant, right? So if say we talk about a first term, say a, then a number like d will get added to every next term, and that is the reason why the common difference is fixed. I'm sure all of these basics you people must be knowing. It was just a little bit of revision that I did with you people. Now children, I will quickly discuss the formulae which are normally used in this topic, and after which we will be discussing the sum. So the first thing is that if you talk about the arithmetic progression, then the common difference small d is given by the difference of the second term and the first term, and that is further equal to the difference of the third term and the second term, right? So this is the basic characteristic of an arithmetic progression. After this guys, the next rule that you normally do follow in talking about the nth term of an arithmetic progression is Tn, or the nth term, is given by a plus n minus 1 times of d. Now here a is the first term, n is the number of terms, and d is the common difference, right? Further after this guys, we have another important formula which here in the sum also we'll be using. That is, if you talk about the sum of n terms, it is given by n upon 2 times of 2a plus n minus 1 times of d. Now like I told you earlier, here a is the first term, n is the number of terms, d is the common difference, right? So further quickly discussing all of this again, whenever you talk about an arithmetic progression, you've got to remember that if there is a first term, then to it if you add a constant d, and if you keep repeating this process to get every next term, then such a series is known as an arithmetic series or an arithmetic progression. And the basic characteristic of such an progression is that the common difference which is given by small d is the difference of the two consecutive terms. That is, from t2 if you subtract t1, then that will be equal to the difference of t3 and t2, right? And this is true for any two consecutive terms. Now after this, if you talk about the nth term of an arithmetic progression, then it is given by a plus n minus 1 times of d, where a is the first term, d is the common difference, and n is the number of terms, and tn represents the nth term, which is also sometimes written by small l. Now further guys, if we talk about the sum of the n terms of an arithmetic progression, it is given by Sn, and that is n upon 2 times of 2a plus n minus 1 times of d. Now here guys, a is the first term, d is the common difference, n is the number of terms, and obviously Sn is the sum of these n terms. That is, it is just like t1 plus t2 plus t3 and so on up to tn, right? So these are the three formulae that are there in arithmetic progression that we're going to now apply so that we can get to the solution of the sum that is next for you people. So guys, now this is the question. So this is the time when you require to pause the lecture and quickly give the sum a try, right? So I'll give you a few seconds when you can form your strategy and try out the sum, and after you haven't been able to do then you can look up the sum, or probably if you've been able to do, then also do look up the solution to check whether you've done it correctly or not, right? Now give it a try. I'll give you a little time. Go ahead. Okay guys, now let's consider that you have given it a valiant try, and now you're looking for where you made some errors, or probably you really want to look how the sum is going to be solved, right? So here now what we do next is, if we talk about the sum, we have here, if the sum of n terms of two arithmetic series are in the ratio of 2 plus 3n is to 3 plus 2n. So there are two different arithmetic series that we are going to talk about, and we have the ratio of the sum of n terms of both of these series. So let's quickly write it. The thing that has been given to you is, we've been given, say, the sum of n terms of the first series to be capital Sn, and the sum of n terms of the other series to be, say, some small sn, and the ratio of both of these has been given to you, right, to be equal to 2 plus 3n, which is divided by 3 plus 2n, and this is how we write the ratio as a fraction, right? So further now, after this, here we will also be writing the formula of the sum of n terms, so that now we can simplify this. So if you talk about any Sn, then you know this, that is given by n upon 2 times of 2a plus n minus 1 times of d, right? We've just discussed this, and now we are going to use this formula. So further guys, next what's going to happen is we will now substitute this formula in the numerator for the first series and for the second series. Now remember, as these are two different series, so obviously here what we'll have is, for the first series the first term will be different, and for the second it will be different. Similarly, for the common difference of the first term of the first series and the second series will both be different. So let's consider the sum of n terms which has been written by capital S. Let's say its first term be capital A, right, and its common difference also be represented by capital D. So here guys, we can write this as n upon 2 times of 2a plus n minus 1 times of capital D, right? And further now, if you talk about the other series here, we are going to write the first term and the common difference by small letters. As such, now we have n upon 2 times of 2a plus n minus 1 times of small d, and here guys we get to see that n upon 2 will get cancelled from the numerator and from the denominator, and further we will now just be left out with 2 times of capital A plus n minus 1 times of capital D, which is divided by 2 times of small a plus n minus 1 times of small d. And guys, this has been given to you to be a ratio which is 2 plus 3n, which is divided by 3 plus 2n. Right now, remember guys, this is true for any value of n. So if you keep the value of n to be 3, or if you keep the value of n to be 33, always this is going to be true. That means when we talk about these two series, the ratio of the sum of the n terms can be found out by keeping the value of n to be that number of terms that we are going to talk about. Like suppose if we talk about the number of terms to be 14, then that's going to become equal to 2 plus 3 times of 14 upon 3 plus 2 times of 14, and then obviously this will get calculated to a fraction, and that will then be the ratio of the nth term of both of these series. Right now here guys, if you look up further what's been asked to you in the question, that is this: find the ratio of the 7 terms. So one thing is pretty spooky, and that is this, that you've been given the ratio of the sum of n terms and you've been asked the ratio of the nth terms, right? So obviously both of these are different formulae. Like if you talk about the sum of n terms, this is the formula, and if you talk about the ratio of the nth terms, then this is the formula. So how do we do this? Because this is something which is very different, because both of these have different formulae. As we've been given the sum of n terms, so how do we find out the ratio of the nth terms? Now for this, children, we do a single thing. Like I told you, as this equation will be true for any value of n. That means for any number of terms that we take of the first series and of the second series, the ratio will remain to be the same. As such, let's say we want to replace this n with some value which is 2m minus 1, and here guys you'll get to see the advantage how by using this specific value of n, which is 2m minus 1, which is just like 13, 53 or any other number, can help us in finding out the ratio of the nth terms, right? So next, now what we do is we now place in terms of small n for nothing, m for money, right? So that obviously doesn't mean that there's nothing or nothing of financial resources, probably there's no money. It's nothing like that, just n for nothing and m for money is being considered, so that we can understand what these letters are, because these letters sound quite a lot the same, right? So if say we talk about 2a plus n, right, in place of n now we are going to keep this 2m minus 1, and then further we will multiply this with capital D, and further then we talk about the denominator, that is 2a plus we will have in place of n now guys we have to keep here 2m minus 1, and remember in the numerator there was also a minus 1, right? So just the value of n is 2m minus 1, and after that we also have to write a minus 1. So further in the denominator also we will write 2m minus 1 minus 1, and here the common difference is small d, and this ratio here is 2 plus 3 times of, again here also in place of n we will be substituting 2m minus 1, so it will become 2m minus 1 upon 3 plus 2 times of, in place of n, 2m minus 1, right? And further guys, here what will happen is in the next step this is going to become equal to 2a plus 2m minus 2 times of capital D, and this is going to be divided by 2 times of small a plus 2m minus 2 times of small d, right? And that guys is going to become equal to 2 plus 3 into 2 is 6m minus 3 divided by 3 plus 4m minus 2, right? Now children, here what we get to see is in the second term of the binomial on the left hand side, in the numerator as well as in the denominator, we can take the 2 outside, so we have 2a plus 2 times of d times of m minus 1, right? And similarly in the denominator we have 2 times of small a plus 2 can be taken common out from the binomial, and times of small d times of m minus 1 is what we have. And on the right hand side guys, on solving this further, we will get 6m minus 1 in the numerator, and in the denominator we have 4m plus 1, right? So further now guys, we find that in the binomial on the left hand side, in both the terms we have 2 common, so we can take that 2 common outside, and inside then we will be left out with capital A plus d times of m minus 1, right? And in the denominator we have 2 times of a plus d times of m minus 1, right? And this guys is equal to 6m minus 1, which is divided by 4m plus 1. And if you further write this, we have both of these 2's which will get cancelled, and then we will get a plus m minus 1 times of capital D, which is divided by small a plus m minus 1 times of small d, and here the ratio is equal to 6m minus 1, which is divided by 4m plus 1, right? And here then guys, what will happen is on the left hand side you have here the nth term of the first series, because if you remember the formula of the nth term was Tn is equal to a plus n minus 1 times of d, and here what we have it something like that, that is it is a plus m minus 1 times of d of the first series. As such, it can be represented by capital Tn. And then further after that we will now talk about the denominator, which now has become the nth term of the other series, which has been represented by small letters. And now if you talk about the right hand side, it still remains to be 6m minus 1, which is divided by 4m plus 1, right? Now guys, we will be talking about here in place of n, actually we are talking about the nth term, so we will now be talking about the nth terms. And since here we've got to find out the ratio of the 7 terms, so as such what we do is in place of this m we will now be substituting 7, right? So as such now we will have t7 upon small t7, which will then be given by 6 times of 7 minus 1 divided by 4 times of 7, right, plus 1. Now further, when we solve this will give us 42 minus 1, which will be divided by 28 plus 1, and that, guys, is going to become equal to 41, which will be divided by 29, and this, guys, is the ratio of the 7 terms of both of these arithmetic progressions, and this will then become your final answer. Now, if this comes as a multiple choice question, then obviously here there can be 4 answers to this question, like 1 be the correct answer, which is 41 upon 29, and except that we can have 3 more answers. Let's say we can have 43 upon 23, then we can probably have another answer which is 45 upon 29, say, and similarly we can probably have another answer which is 1 upon 2, right? So out of these 4 answers, you know that this is the one which is correct, and after solving this, then you will come to this conclusion that probably any option like option B or option C, which has 41 upon 29, will become the correct answer, right? So now, guys, I'll quickly be discussing the sum all over, so that if there is any portion which you haven't understood, all of that gets perfectly clear. In the question, you've been given here that the sum of n terms of 2 arithmetic series are in the ratio of 2 plus 3n and 3 plus 2n. That means here we are not just talking about one series, but we are talking about 2 series simultaneously. So if we consider the first series be represented by capital letters and the second be represented by small letters, then capital Sn upon small sn has been given to you to be 2 plus 3n upon 3 plus 2n. Now, as, guys, we know that Sn, that is the sum of n terms, is given by n upon 2 times of 2a plus n minus 1 times of d. So here what we do is, if we keep this in the numerator and in the denominator, considering this, that capital A is the first term of the first series and capital D is the common difference of the first series, and for the second series we have small a to be the first term and small d to be the common difference, then we will have in the numerator n upon 2 times of capital A plus n minus 1 times of capital D, which is divided by n upon 2 times of small a plus n minus 1 times of small d. Now here, guys, as n upon 2 is in multiplication in the numerator and in the denominator and also common, so it will get cancelled, right? And further, then we will now have just whatever was in the bracket in the left hand side, and here the right hand side will remain to be the same as has been given to you in the question, right? Now, children, here if you talk about this, then this mathematical statement is actually true for any value of n for the given series, right? So if you talk about the 4th term or if you talk about the 43rd term, right, the sum of the first 4 terms, right, will give you this ratio. Or if you talk about the sum of the first 43 terms, even then the ratio on keeping in place of n 43, you will get the same answer. However, here if we keep in place of n 2m minus 1, right, then what happens is, as in the question, we've been given a pretty absurd thing, that is, we've been given the ratio of the sum of n terms, and we've got to find out the ratio of the nth terms, that is the 7th terms, right? So it is pretty absurd, because if you look up here, the formula for this nth term is a plus n minus 1 times of d, and the formula for Sn is n upon 2 times of 2a plus n minus 1 times of d, right? And that is the reason, as both of these have different formulae, so we have a strategy here, that is, if in place of n, if we keep 2m minus 1, as this equation is true for any value of n, so obviously for 2m minus 1 it'll still work, right? So now we substitute in place of n 2m minus 1, so we have 2m minus 1 times of capital D, and in the denominator also, where there was n, we are now going to substitute 2m minus 1 and then minus 1 times of small d. Now in the right hand side, wherever there is small n, again we are going to substitute 2m minus 1 in the numerator as well as in the denominator. Now on the left hand side, guys, this is going to become in the bracket 2m minus 2, as minus 1 will make it 2 in the numerator as well as in the denominator. Further, we find that here from the bracket we can take 2 to be common outside in the numerator as well as in the denominator and multiply it with d, and that is what we've done here. Further, if you talk about the numerator as well as the denominator, then in both the terms of this binomial, we have 2 which can be taken common outside and cancelled off from the numerator and from the denominator. Thus, in the numerator, we are left out with a plus m minus 1 times of d. And in the denominator, we are left out with small a plus m minus 1 times of small d, right? And if you compare this, this is very easily comparable to the formula of the nth term of an arithmetic progression, which is a plus n minus 1 times of d, and this is the standard formula. As such, you can say that in the numerator you have tm here, as it is the mth term which will have in place of nm, right? And in the denominator you have the mth term of the other series, which has been represented by small letters. On the right hand side, obviously this was further solved, right? And you got to 6m minus 1 upon 4m plus 1. Now here, as we require the ratio of the 7 terms, so in place of m, guys, we're going to substitute 7 on the left hand side in the numerator and in the denominator, and similarly on the right hand side in the numerator and in the denominator. So we have 6 times of 7 minus 1, that is 42 minus 1, that is 41 in the numerator, and in the denominator we have 4 times of 7, that is 28 plus 1, that is 29. So 41 upon 29 becomes the final answer. So are you guys clear about this? For sure. So if a sum like this comes, do crack it. And I told you one thing more: if suppose it's a multiple choice question, then accept this to be one of the correct answers. You will probably have 3 more answers, so after the calculation I'm sure you will get to the correct answer, and then in the multiple choice question you can mark that option to be correct, right? So remember, whenever there is any question, even if it is of proving, you can very easily convert that to a multiple choice question, right? And I'm sure you must have understood this, and if there is any step which you haven't understood, then make sure you write that in the comment section, and also do tell about what other topic would you like me to cover, right, that you're not very sure of, right? Do remember that I have also courses to which I can provide you access when you do send an email in saurabhkumardutt@gmail.com, right? There you will get the whole set of all the different type of sums and the concepts which are required for a specific chapter, right? So the moment you say, you will be provided access, right? So make sure, guys, that you do watch this again if you require, and also do send it to such sort of other students who require it, and do help everybody, as when you help somebody, I'm sure God also helps you out in some way, right? So do work hard, and do let me what are the other things I can help you with. Bye for now, guys, and have a nice time. Bye.